Hey, what's up? It's your old pal, Mr. Cook, and we're working on the Unit 7 extra review. So make sure that you have out your identity sheets and then also your formulas like the double angle, half angle formulas, and a unit circle would probably be pretty helpful too. Okay, so let's go ahead and work through these. It says to use a separate sheet of paper, so I'm gonna get some scratch paper also. All right, so some scratch paper. Now, this first identity is pretty obvious. That's this cofunction identity, so that turns into into sine. So this would be secant of x times sine of x, and that's using a cofunction identity here. And then secant, that's a reciprocal identity. We can turn that into 1 over cosine. And if we multiply those two together, we end up with sine of x over cosine of x. And that one obviously is a quotient identity, and that just turns into tangent. So tangent is what you can simplify that to be. All right, now let's try the next one. So I've got cosecant over tangent plus cotangent. So general rule of thumb is if we have like a bunch of different identities, turn them into the same kind of stuff, so sines and cosines. So I'd use a reciprocal identity for cosecant, and then quotient identities for the bottom ones. So then that would be cosecant is 1 over sine, then tangent is sine over cosine, cotangent is cosine over sine. Then I would find the common denominator in the bottom there, so you have 1 over sine of x over, and then that would be, let's see, multiply the top and the bottom by sine, so that'd be sine squared over sine times cosine. So sine times cosine is going to be your denominator for that. And then this one's going to be times cosine over cosine, so that'll be cosine squared. And cosine squared plus sine squared, that's just 1. That's a Pythagorean identity. So this turns into 1 over sine of x over 1 over sine of x cosine of x. And then when you have a fraction, divide by a fraction, it's the whole like keep, flip, change kind of thing. So this turns into 1 over sine of x times, then it'd be sine of x times cosine of x over 1. And then this just becomes one big fraction, so that'll be sine of x cosine of x over sine of x, and then the sine of x's cancel out, and you just have cosine of x for your answer. And that's the simplified expression. For number 3, perform the addition and simplify. So again, find the common denominator if you can. I would first turn all that stuff into sines and cosines personally. Or would I? Let me think. Yeah, I'd probably do sines and cosines, because like the other option, let's do the common denominator thing, because that'd be pretty easy to do. All right, so you can do sines and cosines, you'll end up with the same answer that I'm going to get, but I noticed that like if I multiply the top and the bottom by tangent, or I'm sorry, not by tangent, by this one's denominator, so cosecant over cosecant, and then I multiply this one by this one's denominator, so tangent over tangent. Then I end up with the following. So tangent times tangent is tangent squared. And then like since cosecant is 1 over sine, if I do 1 over sine times sine, that's just 1. So tangent squared plus 1 over, and then that's going to be tangent of x times cosecant of x. Tangent squared of x plus 1. If you look on your identity sheet, that's a Pythagorean identity. That's just secant squared. Now let's see what tangent of x times cosecant is going to be. So tangent of x is going to be sine over cosine, so sine of x over cosine of x. And then cosecant is 1 over sine. So like the sines cancel out. And then you have secant squared of x over 1 over cosine. And then remember, like you multiply by the reciprocal there, so that's going to be secant of x squared times cosine. And remember that like cosine is 1 over secant. So like one of those secants is going to cancel out, and you're just left with secant all by itself. So that'd be what it simplifies to be. And then let's write out our identities that we used. So I just used the reciprocal identity here, and then I used the Pythagorean identity there. And then let's see, I used the quotient identity to to get from tangent to sine over cosine, and then cosecant to 1 over sine. That was a reciprocal identity. And I was able to cancel out a bunch of that crap. And then, oh, you know what I could have done? I could have just used a reciprocal identity here and call that secant. That probably would have been a little bit easier, but whatever. I ended up multiplying by the reciprocal and then using the reciprocal identity anyways over here, so they cancel out. Okay, now for this one, simplify. So I'm going to leave that sine squared, but the secant squared minus 1, that's a Pythagorean identity. That's going to be tangent squared. So this turns into sine squared of x over tangent squared of x. And then I'd use a quotient identity for this one and turn that into sine over cosine. So that'd be sine squared of x over sine squared of x over cosine squared of x. And then, you do the keep flip change or whatever. So sine squared of x times, then it'd be cosine squared of x over sine of x, the reciprocal of the denominator. The sines cancel out, and you're just left with cosine squared of x as your answer for that one. Okay, looks like we have three more simplify problems. So let's do those as well. So this is 1 over cotangent. So that's really just tangent, like that's a reciprocal identity. So that's what I'd use there, turn that into tangent of theta, and then plus 1 over tangent of theta. Now, I just find the common denominator, so what I do is I multiply the top and the bottom here by tangent theta. So then this turns into tangent squared of theta plus 1 over tangent of theta. Tangent squared of theta, that's a Pythagorean identity. So I would use that and turn it into secant squared. And then, let's see. And then I could do the whole, sines and cosines thing for this. So secant squared is 1 over cosine squared. So that'd be the reciprocal identity I'd use there. And then tangent squared, I'd use a quotient identity, and that would turn into sine over cosine, sine squared over cosine squared. And then, let's see here. So I'd multiply by the reciprocal. So let's go this way. So then it'd be 1 over cosine squared of x times the reciprocal of this, which would be cosine squared of x over sine squared of x. The cosine squareds cancel out, and you just have 1 over sine squared, which is the same as cosecant squared. So that'd be our answer overall for that one. Let me think, could you have done that a little easier? So that's cotangent, that's tangent. Yeah, I guess you could have turned both of these using reciprocal identities into tangent and cotangent respectively, and then just use sines and cosines the rest of the way. So that could have worked also. 6, so factor and simplify. All right, well, let's see here. I've got a secant, a cosecant, and a 1. I don't know, I'd probably just group these two together and factor out a common factor. So notice that they both have secant squares. So I'd factor out the secant squared. So I have secant squared of x on the outside of the parentheses, and then on the inside of the parentheses, if I take out the secant squared here, I'd have cosecant squared. And if I divided this negative secant squared by secant squared, I get a negative 1. And then I have minus cosecant squared of x plus 1. And then cosecant squared minus 1, if you use your Pythagorean identities, that's cotangent squared. I guess I could do that. Oh wait, actually, whoa, I just realized that we could do, we could factor out a cosecant squared minus 1, because this thing right here is the same as saying negative 1 times cosecant squared minus 1. So if I have a cosecant squared minus 1 here and a cosecant squared minus 1 here, I could factor that out because these are common factors of these two. So if I did that, I'd have cosecant squared of x minus 1 factored out. And then what would I have left over if I got rid of this and this? I'd have secant squared minus 1. And yeah, that's pretty nice because this turns into, it's a Pythagorean identity. That's just cotangent squared. And then this is tangent squared. And then these are reciprocals of each other, so I could turn that into 1 over tangent times tangent. And then the tangents cancel out and you just have 1, so 1 is your answer overall. Whoa, that's pretty weird. I like that. That's a neat problem. Probably a little a little bit too difficult for like anything we'd ask on a test, but you know, still pretty interesting one. Okay, now we got factoring and simplifying. This one is pretty close to the one that you had on your partner quiz. Cotangent to the fourth plus 2 cotangent squared plus 1. This just factors, you know, so it's like if you use the cotangent squareds as like, you know, y's or whatever, that'd be y squared plus 2y plus 1. So numbers that multiply together to be 1 and add together to be 2, those are going to be 1 and 1. So this turns into cotangent squared of x plus 1 times cotangent squared of x plus 1. And then these are both cosecants if you use your Pythagorean identities here. So you get cosecant squared times cosecant squared. And then cosecant times cosecant is cosecant squared times cosecant squared is cosecant to the 4th power. And that'll be your answer for number 7. And then we'll do number 8, and that'll be it for this video, and move on to the next one. So rewrite the expression so that so that it is not in fraction form. Okay, well, I would use the Pythagorean identity because I see right away that like this is a factor of 1 minus sine squared. So I'd turn this into 1 minus sine squared using Pythagorean identity. So that's 1 minus sine squared of theta, or sine squared of x, over 1 minus sine of x. Because this is a difference of squares problem, so I can factor that, and then it'll turn into 1 plus sine of x times 1 minus sine of x over 1 minus sine of x. And then do you see what happens with the 1 minus sine of x is they just cancel out. And you get your answer, 1 plus sine of x. So there you go. Now it's not a fraction, and it's simplified. So that's like a good chunk of work. I probably should have used a separate sheet of paper for some of that, like these ones where it's a little bit more steps than I'm used to, but you know, they're not that bad. All right, so that's numbers 1 through 8, and on to the next video.